I welcome you all to the last part of this particular course, which is the Some Basic Concepts of Chemistry Part 10. And so far, you must have got a lot of knowledge about what is chemistry and what are all chemical reactions and what are atoms, molecules, compounds, and everything, and what are the terminologies that are used in chemistry in a basic ways. So in the last part, what we are left with, it is just a continuation of the previous part 9, where we were discussing about the concentration terms that can be used to express the concentration of various solutions. And here we will be discussing about what is the last concentration term that is left, which is normality. So, normality is another kind of a concentration term which can be used to express the concentration of the solution that you have prepared. So, let's begin with understanding what is normality, and we'll do some questions related to normality to understand the
normality
concept of
is
normality
represented
in a
by a
better way.
symbol capital N, and it is just similar to molarity, but there is only a borderline difference between the two. It is similar to molarity that we had done in the last class, but there is just one borderline difference. And what is that borderline difference? That normality, represented by capital N, is the definition is it is the number of gram equivalents of solute divided by the volume of solution in liters. And there, when we were discussing about molarity, which is capital M, it is the number of moles of solute divided by the volume of solution in liters. So there is a very slight difference between the two. Okay. Now, what is these gram equivalents? Actually, the gram equivalents, or they are also called as equivalent moles. There, when we were using molarity or capital M, we were talking about only moles. But when we discuss about representation of the concentration in terms of normality, which is capital N, we take into numerator gram equivalents. Gram equivalents of equivalent moles is nothing but the given mass of the solute divided by the equivalent mass. So instead of using molar mass or molecular mass, we say equivalent mass. And I will just tell you what is equivalent mass and what is the difference. But just remember that gram equivalents or equivalent moles, which you see in the numerator, it is nothing but the given mass by the equivalent mass. So I can just rearrange my whole expression and can say that normality is nothing but equals to the given mass or the mass of the solute divided by equivalent mass into volume of solution in liters. Now let's understand everything we know what do you understand by mass of solute. Till now we know volume of solution in liters, how you can convert it. But what is this equivalent mass? Now this is a new term for us right now. So equivalent mass is nothing but the molar mass or the molecular mass of your solute divided by n factor. Now what is this n factor now? Now the n factor is actually a factor which is dependent upon, whose value is dependent upon the kind of solution you are, whose concentration you're trying to find out. Okay, so in normality, whenever we make normal solutions, so normality means making normal solution, molarity means making molar solutions. Okay, so in normality, whenever we make normal solutions, if I tell you please make two normal solution of an acid, so you are going to first check how much amount of your solute you are going to take. The amount of solute that you are going to take will be dependent upon the n factor, because in the formula you need to find out the equivalent mass. Okay, then only you will be able, if I know the normality, for example, I tell you please make two normal solution. So if I tell you to make two normal solution of an acid, so two normal solution, I know the normality, I know the volume, how much, 500, let's say make two normal 500 ml solution of, or 1 liter solution, two normal 1 liter solution of an acid. So you know the normality, you know how much amount of solution needs to be made, that is 1 liter. But what you don't know right now is the equivalent mass and the mass of the solute that you are going to take. Your mass of the acid that you are going to take and equivalent mass you don't know. You can easily find out the equivalent mass. Yes, you can find out by this formula. But still, what is the problem? This n factor. How to calculate this n factor? If you get to know this n factor, you can easily calculate the equivalent mass, because molar mass will be given, will be actually, you will be knowing what is molar mass. So if you find out the equivalent mass, mass of the solute which was unknown, you can always get to know, okay, this is mass of the solute that I need to weigh on the analytical balance to make two normal 1 liter solution of my acid. So for that I need to find out equivalent mass, okay, and for finding out equivalent mass I need to find out the n factor. So the values of the n factor will be dependent upon what kind of a solution you're making, whether it's an acidic solution or a basic solution, or you're making a solution of an atom, or you're making a solution which is in ionic form. So what kind of a solution you are making will be deciding the what would be the value of this n factor, and from there you can easily calculate equivalent mass. You can just put in this formula and you can find out the mass of the solute that would be required to make two normal 1 liter solution of the acid. Okay, so let's find out how can you find out the n factor. If you are making an acidic solution, the value of n factor would be dependent upon the number of H plus ions that would be displaced in an acid. Okay, so the number of H plus ions that you will be having will determine the value of the n factor. So for example, let's say I want to make some oxo acids. Now what are oxo acids? First understand that oxo acids are those acids in which the central metal atom or the central element of the oxo acid is connected by at least one double bond O. So it is connected by oxygen by a double bond. So oxo acids are those acids in which the central element is connected to an oxygen atom by a at least one double bond. So whenever there is at least one double bond between the central element and the oxygen atom, then we call it as an oxo acid. And the various examples of oxo acids are H2SO4, H3PO4, and H2CO3 carbonic acid. Okay, so these are all the examples of oxo acids wherein you are going to see the central element being connected with the oxygen atom by a double bond. We'll just discuss it. And how will you calculate the n factors in that? The n factor value will be calculated in oxo acids, where in which way that your OH group will only be, obviously in oxo acids it would be the rest of the valencies would be fulfilled by OH groups, and the OH groups will be the only one which are going to release the H plus ions and will get displaced eventually. So the OH group, the number of OH groups are going to discuss the value of n factor in oxo acids. So for example, H2SO4 is, this is a structure of H2SO4, and the sulfur is connected with two of the oxygen atoms with double bond, and single bonds are there with one of the oxygens, and the oxygens then are connected with the hydrogens. So there are these two groups, OH groups, which are going to replace or displace their hydrogens, and thus the n factor for H2SO4 is 2. Let's say if I'm talking about phosphoric acid H3PO4, the structure of H3PO4 is this, and the phosphorus atom is connected to this oxygen by a double bond. So there is one double bond, central metal atom connected with oxygen atom with a double bond. So this will be an oxo acid, and since there are these three OH groups which are going to displace their hydrogens, so the n factor for phosphoric acid is 3. If I'm talking about carbonic acid, the structure is this. So this you can see there is this carbon oxygen double bond, so this is an oxo acid, and there are these two OH groups which are going to release their H plus ions, so the n factor becomes 2. So whenever we are talking about acids, the n factor will be dependent upon the number of hydrogen ions that could be released by the OH groups in it. Okay, so you need to remember the structures of your acids, some of your common acids. If I'm talking about base, so we will be if whenever there will be base, obviously we'll be seeing that how many of OH groups, OH minus ions are actually present, hydroxide ions, OH minus ions that are present, that can accept the H plus ions. So for bases we will be just seeing how many OH minus ions are present. So for NaOH, one OH ion minus ion is present. Then so for NaOH, only one OH minus ion is present. So the N factor would be 1. For calcium hydroxide CaOH twice, there are two hydroxide ions that are present. So OH minus ions are 2. So N becomes equals to 2. For this base, there would be 3 OH minus ions that would be present, so N becomes 3. So for all of them, we just need to understand how many OH minus ions are present. So if I'm talking about atoms, we just see their valencies. So for sodium, we know the valency of sodium is 1. For aluminium, it is 3. It can combine with 3 of the other groups. So its valency becomes 3. So N will be 3. For fluorine, it can only combine with one other atom. So its valency would be 1. Calcium 2 and oxygen 2. So depending upon what are the valencies of the atoms, the N factor value would be decided accordingly. If I'm talking about ions, so whenever I'm talking about ions, I have to see what are the charges that are present in it, and that would decide the value of N factor. So for if I'm talking about iron, in plus 2 oxidation state, it says plus 2 oxidation state. So I can the charge on the iron is plus 2, then the N factor for it would be 2. If I have for chloride ion, if it is minus 1, then N factor would be 1. For nitrate ion, it is minus 1, but the N factor would be 1. So whatever number of charge that is present over the particular ion, that will become its N factor. Now, if I talk about some electrochemical reactions where the electrons would be released and accepted, the N factor can be determined as, let's say I have a reaction where zinc reacts with copper sulfate to give me zinc sulfate plus copper. Now here you can see the oxidation state of copper over here is plus 2, and here zinc is in its native state, and whenever zinc or any metal is in its native state, the oxidation state is 0 over it. Please remember that. So whenever your metals are present in their native state, the normal form, the native forms, then the oxidation state of the metal becomes 0. So here zinc would have an oxidation state 0. Copper has plus 2 oxidation state. Here zinc has plus 2 oxidation state because sulfate has minus 2. So zinc has plus 2. Copper is in its native state. It has 0 oxidation state. So what has happened? Copper has gone from plus 2 oxidation state to 0 oxidation state. So reduction has occurred, and zinc from its 0 oxidation state has moved to plus 2 oxidation state. So oxidation has occurred. And what is the difference of the electrons? That is this, the difference of the electron. This has accepted the electron. Okay. So whenever there is or you can say there is, sorry, it has, zinc has lost the electrons. So 2 electrons has been lost from zinc. Since the zinc has lost the electrons, it has gone from its 0 oxidation state to plus 2 oxidation state. Oxidation has occurred, loss of electron has occurred, and how many electrons have been lost? 2, because from 0 to plus 2, 2 electrons has been released. So if 2 electrons has been released, oxidation has occurred, and the N for zinc becomes 2. Similarly, for copper, here it is plus 2 oxidation state. Here it becomes 0. That means copper has eventually has undergone reduction. Reduction means acceptance of electron. That is, the copper here has undergone reduction from plus 2 oxidation state to 0 oxidation state. It has undergone reduction. It has accepted electrons. And how many electrons it has accepted? It was plus 2 here. It is 0 here. It has accepted 2 electrons. So copper accepts 2 electrons, the N factor is 2 for this. Zinc gives away 2 electrons, and its N factor is equals to 2. So the number of electrons that are released or accepted by a particular species decides the value of N factor for it in an oxidation reduction reaction or a redox reaction. Okay, so this is how, this till now we have just discussed how you can calculate N factor, and once you have calculated N factor, you can calculate the equivalent mass. Once you have calculated the equivalent mass, if you know the mass of the solute, if you know the volume of the solution, you can very well calculate the normality. Through questions, certain questions, that's just to make you understand what I mean by normality, how can you calculate normality and everything. So the question says, find the normality of a 500 ml aqueous solution of nitric acid HNO3 prepared by adding 31.5 grams of HNO3 in water. So what is given to me? The mass of nitric acid is given to me, which is 31.5 grams. Volume of the solution is given to me, which is 500 ml. Now, first, what I need to do, I need to find out the N factor. So, okay, so mass of the solute is given to me. Volume of the solution is given to me. I need to find out the equivalent mass. If I find out the equivalent mass, I can easily find out the normality of the solution, because that is what asked in the question. So, the N factor for nitric acid, please remember this is the structure of nitric acid, okay, and you can see there is only one OH group, or there is one OH group which can replace its hydrogen. So the N factor for nitric acid is 1. So my equivalent mass will be the molar mass of nitric acid, which is 63, divided by the N factor, which is 1, which will remain 63 grams. So the normality will be the mass of the given mass of the solute, which is 31.5, divided by equivalent mass 63 into the volume of the solution 500, but the volume of the solution is in ml. You need to calculate in liters. So 500 divided by 1000, 1000 will move in the numerator. So it would be the given mass of my solute into 1000 divided by equivalent mass into 500, which will come out to be 1 normal. So the normality of the solution, which is prepared by adding 31.5 grams nitric acid in water, forming 500 ml aqueous solution, will be 1 normal. So the normality of the solution is 1 normal. Okay. Next question. If 49 grams of sulfuric acid H2SO4 is added to water, a 250 ml solution is prepared. Okay, so whenever I add 49 grams of sulfuric acid to water, a 250 ml solution is prepared. Find the normality and molarity of the solution. We need to find out the normality and molarity of this particular solution. Now, what is given to me? First, write the givens. Mass of the solute is given to me, which is sulfuric acid, which is 49 grams. Now, volume of the solution that was prepared was 250 ml. Okay, so this 250 is nothing. This will be volume of the solution, and we can divide it by 1000 to make it liters, because volume of the solution needs to be converted into liters. So 250 divided by 1000. This is done. Now mass of the solute is given to me. So we all know we need to find out molarity first. So let's find out molarity. Molarity is nothing but given mass of my solute into 1000 divided by molar mass into volume of solution, right? So given mass is 49 grams into 1000 divided by molar mass of H2SO4 is 98 into 250 is the volume of the solution. This 1000 is because we have converted 250 ml into liters. So this comes out to be 2 moles per liter, or I can say capital M, or molar. Okay. So 2 is the answer. Now let's calculate the normality. So normality is given mass. So just compare the two formulas, please. Given mass into 1000, same, divided by volume of the solution, same, but here molar mass is not there, it is equivalent mass. So equivalent mass is nothing but, we know, molar mass divided by N factor. For H2SO4 we know there are two OH, we just discussed, for H2SO4 there are two OH groups that can replace their hydrogens. So N is 2, so equivalent mass will be molar mass divided by N factor, that is 98 divided by 2. So this comes out to be 4 equivalent mole by liter, or I can say 4 normal, or 4 N. Okay, so this is how we have calculated molarity and normality. Now just see the values. Now this 4 is nothing but twice of molarity. This 4 is equals to twice of this 4 is equals to something into molarity. Now this, what is this something? Okay, this would be nothing but 2 into 2. If I do 2 into 2, I just multiply this molarity into 2, that will come out to be 4 normal. If I multiply my molarity 2 into 2, this will come out to be 4 normal, or 4 equivalents by mole by liter, right? So what is that 2? The 2 was N factor. So in general, just remember this one formula in general, that your normality is always equals to N factor into molarity. So whatever is your normality, that will be equals to N factor. The N factor here was 2. So if I multiply my molarity by 2, I will get what? Normality. So normality, please remember, is always equals to N factor into molarity. Normality is always equals to N factor into molarity. So if I know the value of if I know the value of N factor, if I know the value of molarity, just multiply the two. You don't need to do these calculations. If you know your N factor, here it was H2SO4, N factor was 2, molarity came out to be 2. 2 into 2 means 4N. for normal solution. Directly you just don't need to use these two lines also. After finding out molarity, you just need to find out what is your N factor for H2SO4, multiply that with your molarity, you will get normality. So this is the shortcut for finding out the normality if you know the N factor and molarity. The last thing that we need to do is, we have done all the concentration terms that are required to express the concentration of any solution. Now this is the last thing that we need to do, that we will see that what all concentration terms that we have done so far are temperature dependent. Okay, this is what we are going to see next. Before we see that what all the concentration terms that we have done so far are temperature dependent, please remember that whenever you increase or decrease your temperature, okay, whenever there is a change in temperature, that is you increase or decrease your temperature, there will be a change in the volume. Okay, when, let's say for example, I had 100 ml of water in a beaker and I heat it. When I heat it, what is going to happen? It is going to get converted into vapors, and after some time, if I find out the volume, if I put it in a measuring cylinder, earlier it was 100 ml, I heat it, I increase the temperature, it will get converted into vapors, the liquid will get converted into vapors, and after some time when I check the volume again using a measuring cylinder, it came out to be 50 ml. So whenever you change your temperature, okay, whenever there is a change in temperature, the volume of your matter changes. All right, but mass does not change with temperature. That is, it remains the same during whenever you change the temperature. That is, let's say if I have 50 grams of ice bar, and if I start uh, melting it, so what is going to happen? It is going to get converted into liquid, but it will just get converted into liquid. The mass of the liquid will remain the same as that of the ice bar, that is 50 grams. So mass never changes with temperature, it is only the volume that changes with temperature. So whenever in the concentration terms you will have volumes, then it would be temperature affected. But if you do not have volumes, it is just masses which are involved in the concentration terms that we have discussed so far, then it will not be affected by temperature. For example, mass by volume percentage we had done. So, mass by volume percentage is nothing but mass of the solute by volume of the solution, right? Total volume of the solution and that percentage. So obviously since the volume is involved, it is going to be affected by temperature. Mass by mass percentage, in both the cases, there are masses and masses never change it, so it is not affected by temperature. Now comes the molarity. Molarity is number of moles of solute divided by the total volume of the solution in liters. Again, since there is volume term there, it is affected by temperature, because volume is affected by temperature. Molality, the number of moles of solute by the mass of the solvent in kgs. Again, in both the cases there are just the masses involved, it is not affected by temperature. And normality, number of moles of solute, number of gram equivalents of solute divided by the volume of solution in liters. Again, volume of solution is there, it is affected by temperature. So these are all the temperature affected and unaffected terminologies that you're going to memorize it, and just taking into consideration the volume changes and the mass changes. The mass never changes with temperature, volume changes with temperature. So thank you all for choosing this particular course. I am really very thankful to all of you that you have chosen this particular course with me, and I hope that you have got an in-depth of the basic concepts and terminologies for finding out the concentrations and handling your data, how significant figures can be useful, how can they be applied in practical knowledge in chemistry, and you must have got a lot of insight and details and actually the reason for learning chemistry in your everyday life. God bless you all, and all the best to all of you for your future endeavors.
and hope to see you all in our next modules and lectures soon. All the best. Thank you so much.